Okay, friends, welcome to part 1 of my presentation on Introduction to Database Design. In this module, you should be able to learn some of the basic concepts, ideas, and techniques of database modeling. This presentation comes from a textbook by Witten and Bentley called System Analysis and Design Methods, and I've been using this textbook for many years. So if you want to read more about database design, more specifically about ERD approach to database design, I suggest you get this book from the library and read this particular chapter. Now this is chapter 8, I believe, from the book. Once again, this module is titled Introduction to Database Design. In this module we will learn how to design databases. And I would like to give you like a word of caution and a word of encouragement at the same time. You see, like some of the ideas that we will cover in this module, they're fairly, they require some effort to understand. Okay, to be honest with you, I saw some very smart, very experienced people struggling with some of those ideas or concepts. Okay, so I remember when I took a master's level course on database design, there were some people with practical hands-on experience in database design. And yet, it took them some time to understand some of the ideas in relation to database design that we covered in that course. So this is normal. So this is also like a word of encouragement to you. Like, don't think that everything that we discuss, you should be able to understand on the fly. If you do, that's great. If you don't, then don't feel discouraged. It may take some time. Now, on the positive side, everything that we discuss, I think it's highly logical. So, once you put some effort into understanding those ideas, it just makes perfect sense. That's the beauty of any kind of logical approach to things. So overall, this should be a good exercise for your brain to be able to kind of go through those concepts and perhaps even, use those, perhaps once you go through those concepts, you'll be able to use them in your daily life outside of the scope of this class. So I'm pretty sure this class is very useful in many ways. So as a part of this overall agenda of learning about database design, we will try to cover the following learning objectives. First of all, we'll talk a little bit about data modeling in general. We're going to talk about benefits of data modeling and some of the ideas or approaches to data modeling. Then we'll try to make sure that we all understand and recognize basic concepts and constructs and ideas of data modeling. After completing this module, you should be able to read and interpret ERD diagram or entity relationship data models. This module will teach you how to discover entities and relationships. At the end of the day, at the end of this module, you should be able to construct a good entity relationship diagram. And once you construct it, you should be able to make it good, meaning to normalize it. So we'll learn some of the normalization techniques. Okay, so those are the learning objectives for this module. Again, those learning objectives, at this point of time, they're more on the theory side, but you will see that a lot of the things that we learn have a lot of practical implications when it comes to creating actual databases in Microsoft Access. By the way, this module also covers most or all of the ideas in Tutorial A from your textbook. The Tutorial A deals with database design, but we go into much more details than Tutorial A from your textbook assigned for this course. Okay, so what is data modeling? Data modeling is a technique for organizing and documenting systems data. Another term for this is database modeling. So basically, we're learning how to model data or how to create models for databases. Now, this word model, if you look at the dictionary definition of the word model means like some kind of abstract representation of reality. So basically, we're trying to create some kind of abstract representation of the kind of data needs that we will need for our information system or for our database. And once you create this model, this abstract representation, you're in a better position to understand what's needed, what's missing, what are the links, and so forth. More specifically, in this module, we'll learn about the so-called ERD or Entity Relationship Diagram approach to data modeling. So this approach involves utilizing several notations to depict data in terms of the entities and relationships. So at the heart of ERD modeling or Entity Relationship Diagram modeling is recognizing entities, relationships, and also the relationships between or among those entities. And there are several notations or several diagramming approaches that go into that. Now, to give you an example, what we are trying to do, we are trying to make sure that we know how to build something that looks like this figure. What you see in this figure is a very simple entity relationship diagram, or ERD. Now, those boxes, they're used to represent something called entities. So here we have 4 entities. We have 3 kind of normal entities and 1 associative entity. And then those lines are used to represent relationships between or among those entities. So this is how a simple ERD diagram looks like, and that's what we're trying to learn. We're trying to learn the ERD approach to data modeling. By the way, the author, the main contributor to this approach to database modeling is somebody named Peter Chan. If you go to Wikipedia, you can read about him. And the Wikipedia article about ERD modeling says that this whole ERD movement started somewhere in 1976 when Peter Chan published his article on this particular approach to database modeling. So that's what we're trying to learn. We're trying to learn how to interpret and how to build ERD models similar to this one. Okay, let's start with a very basic construct or concept of ERD modeling. This concept is called entity. So let's look at the definition of an entity. An entity is a class of persons, places, objects, events, or concepts about which we need to capture and store data. Read this definition a couple of times to kind of grasp some of the main keywords. I'll just pause right here. So once again, an entity is a class of persons, places, objects, events, or concepts about which we need to capture and store data. I would break this definition into several parts. First of all, entity, I would say entity is something or somebody about which we need to capture and store data. And, the reason I'm saying something or somebody is that an entity can store information about humans and also objects, non-humans, right? For example, an entity can store information about persons, let's say information about agencies, contractors, customers, departments, divisions, employees, instructors, students, suppliers, and so forth. An entity can also store information about places, like sales regions, buildings, rooms, branch offices, campuses. An entity can also store information about objects, both tangible and intangible, like books, machines, parts, products, raw materials, software packages, and so forth. Also, an entity can store information about abstract ideas like events, application, award, cancellation, and also about concepts like account, which is a concept, block of time is a concept, course is a concept, fund, qualification, stock is a concept. Concept means like it's something that is intangible. A concept is something that exists because we agree that this thing exists. For example, our course is a concept because there is that concept that I'll be teaching this course as an instructor, I'll be posting my videos and educational materials. You as students will be attending this course by coming physically to class or watching my presentations online and completing assignments. So that's why it's a concept. It's something that we agreed on, but we cannot really feel, smell, or touch a particular course. I mean, you can argue that, well, we can see the room and we can touch the objects in the room where we hold this class, but again, a room is something that is different. It's a different class, right? We're talking about a course here. So what I'm trying to say is that, first of all, an entity is something or somebody about which we need to store data. Now, the second part of this definition that is important to understand is that an entity is a class of persons, places, or objects. Class means a category. So when we say there is an entity called student, we're not talking about a specific student. We're just talking about a class of people called student. So in other words, there are many specific students out there, but they all fall into this abstract class or category called student. So once again, an entity is a general category of things about which we need to store data. Okay? So there are two important parts to this definition. First of all, it's something or somebody about which we need to capture and store data. And number two, it's an abstract category, right? Now, another thing to remember about entities is that although a class will store information about a lot of specific instances of that class, for example, an entity called student will store information about many students, right? The convention is that entities are named with a singular noun. So we don't name an entity students with S at the end. We name it student. So we use singular noun to name a particular entity. Now you really need to understand that an entity, as we said before, is a class, is a general category. Now this general category will have specific instances, okay? But before talking about specific instances, I would like to say really quick that every entity, such as entity student, eventually is represented with a table, okay, with a table like this. So this table represents this general class or category called student, okay, and then specific rows of this entity, of this table, represent instances, means like specific examples or manifestations or occurrences of a single entity. So as you can see here, each row here represents a specific student. For example, a student named John Taylor, a student named Bill Macy, a student named Heather Leith. Okay, so all those rows, there are specific instances or manifestations of that entity. Okay. Now, if rows represent specific instances or manifestations or examples or occurrences of that specific entity, what do you think columns represent? Just think about it for a second. What do you think columns represent? Okay, if you look at it closely, you will see that, and if you think about it, you will see that columns represent certain properties of that entity, and by extension they represent certain properties of specific instances or specific students right here. Okay, so every row represents an instance of that entity, every column represents an attribute of that entity. So attribute, something that we use columns to represent. An attribute is some kind of descriptive property or characteristic of an entity. Synonyms for an attribute include element, property, and field. I think field is a very common name for an attribute in database design. So basically, you can think of attributes as some kind of properties or descriptors of a specific entity. So here we have, continuing our example of a student entity, here we have the entity itself, and also we have attributes, meaning different ways to describe this entity, or different characteristic of this entity and different characteristics of specific students. So what we're saying here, we're saying that a student would have such properties as name, last name, first name, middle name or middle initial, address, phone number, date of birth, gender, race, major, grade point, average, right? So all those things, they will describe a student. Now, of course, for every entity such as this one, you can include an infinite number of attributes, right? So, for example, some things that can be also included here would be like, student height, student weight, all those things. However, not all attributes should be included. Okay. Now, the rule of thumb here is that you include only attributes that are relevant for running your own business or running your own organization. For example, an attribute called hair color, the one that can store information about color of student hair, we can certainly include it here, but the question becomes, do we need it or not? Okay. Most likely, for the purposes of running a university, we don't need to store information about hair color of specific students. Okay. However, if you're running a barber shop, then maybe you want to keep track of your client's hair color. Okay, but for this specific case, we don't need it. I don't think we need it. Right? The same thing about student weight. I don't think we need to know student weight for the purposes of running a university. Again, if you're running a hospital, then maybe you need to record, customer or client weight or patient weight. So this is like the art of system analysis and design. You need to do your own analysis, your own brainstorming to kind of determine which attributes are relevant and which attributes are not relevant. Now, one thing to note here is that some attributes are compound. Now, compound attribute is an attribute that consists of several parts, or consists of several attributes. For example, name is a compound attribute, and we're using this dot notation right here to show that name consists of such parts as last name, first name, and middle initial. Okay, So some attributes are compound. So what are some other compound attributes here in this entity called student? Just take a look at this. So some other compound entities, compound attributes that you see is address, that consists of the following parts, and then phone number, that consists of area code, exchange number, or number within exchange. Okay. So compound attributes are complex attributes, and the reason we know they're compound is because they're using this dot notation. Now, one thing to note about attributes is that each attribute should have a specific data type. Typically, data types, they fall, they seem to be, they fall into one of those categories. Microsoft Access uses a slightly different version of categorization, but it's very parallel to what you see here on the slide. The reason we need to declare data type for each of the attributes is that we want to make sure that computer allocates proper amount of memory for each of the attribute, for each of the specific value of the attribute that we will store in our database. So basically, this is just to a general explanation is that we need to specify data types to make sure that computer memory is used efficiently by the database that we are designing. For example, your attribute can be number, so it's any number, real or integer. I believe in Microsoft Access they have integer and double. Integer is for a whole number, and double is for decimal point number or floating point number. So if you look at the student entity, an attribute that represents number would be, let's say, postal code. So in postal code attribute we will store a number. Then we have an attribute called text. It's a string of characters, may also include numbers. Okay. An example of a text attribute here in this entity would be last name and first name. Okay, and street address. And street address would be an example of an attribute including both numbers and characters. However, overall it's a text. Then we have something called memo. Memo is same as text, but it's of a larger size or indeterminate size. Here we don't, here in this entity we don't have an example of a memo type, something that clearly seems to be a memo type. But that, an example of that would be, let's say, customer complaint or customer question, right? So a question can be asked like with one paragraph of text, so that would be placed in an attribute with memo data type. Some attributes are of date type, for example, date of birth. Now, some of you may say, well, why don't we use like a number to capture somebody's date of birth? Because at the end of the day, date of birth is captured with numbers. Well, that may not be a good idea because you may want to do certain manipulations with dates. And if you represent your date, like for example, you want to calculate the number of weekends between this particular date and today, that may not be possible if you specify the date, the attribute that stores date as integer. And if you try to convert it automatically, your computer may be very bad at figuring out which date you mean. For example, in the United States they put month first and then day. In other parts of the world, such as continental Europe, they put day first and then month and then year, right? So if you let computer figure out, it may lead to a number of mistakes. So it's better always to specify date as a date type. Time, something that falls sometimes under this date category. Then you have the so-called binary or Boolean, the so-called yes or no data types. For example, graduate student, yes or no, or student status, or student graduation status, graduated, not graduated yet, or male or female. Then you have value set. Value set means there's a finite set of values. For example, level of a student, freshman, sophomore, junior, or senior. So the key here is that it's a predefined value set. Or sometimes it can be even an image. You can have an attribute that stores images, let's say photos of students that we can use for identification purposes. Another thing about attributes is that each attribute has a domain, which is basically a set of legal values or values that an attribute can legitimately take on. For example, you may specify that number can be from 10 to 99. Let's say you're talking about age here. You can specify that text can take any value as long as it's under 30 characters. For date, you can specify the specific format for month, day, and year. For time, you can also specify format. For yes or no, you can specify the range of values is yes, no, on, off, male or female. And then for value set, here, we can use the same kind of value set can also represent two values, meaning like binary kind of variable. So for value set, you can specify like male or female, sophomore or freshman, junior. So you can specify legal values, something that an attribute can a value that an attribute can legally or legitimately take on. Okay. Another thing about attributes is that some attributes may have default value. Default value means the value that will be recorded if a value is not specified by user. So for example, by default, you can specify that a student is a freshman. Typically, default value is the value that is most common. For example, let's say we're talking about Murray State University, and we're creating a database to store information about students. And one of the attributes of the entity called student is, let's say, campus. Okay. Now, so basically, what we want to do, we want to keep track of which campus a particular student is assigned to. And let's say we have 3 campuses. We have the main campus, the campus in Murray, the main one. Then let's say we have a side campus in Paducah and another campus in Henderson. Okay, so by default we may want to indicate that a student comes from Murray because that's where most students attend the university, right? However, a student can change, we can change this value from default value of Murray to Henderson or Paducah, but most students are assumed by default to be coming from Murray. Of course, you need to be careful with default values because sometimes respondents or sometimes people who enter information to databases, they're either too lazy or they're simply in a rush and they may skip this default value. For example, somebody is attending Murray State University in Paducah, but because they didn't see it or they were in a rush, they fail to change this value. So sometimes it's better to kind of specify a field as required, and it's better not to give any default values, okay? Because it may lead to data quality problems. Okay, another important thing about attributes, another important idea in relation to attributes is that each entity should have a key. Okay. Now, key is an attribute or group of attributes that assumes a unique value for each entity instance. Okay, it is sometimes called an identifier. So basically, a key is an attribute that assumes unique value for every instance of that entity. So let me to explain better what we mean by key. Let me give an example of an attribute that doesn't assume a unique value for each individual instance of an entity, and that example would be gender. Okay. Now, gender does not uniquely identify a specific person. So, for example, let's say a police officer asks you to identify, a particular person. In other words, like a police officer says, "Okay, like we're looking for this for this specific person who committed a crime on campus, God forbid." So the police officer will ask, "So, can you give me can you describe that person?" And if you tell the police officer, "Well, I believe that the suspect is male, right? Or female," then that would not be enough for the police officer to uniquely identify the suspect because there are many males and females on campus. Okay. However, if you give the student number of the suspect, let's say the suspect dropped his or her student ID at the crime scene, right? In that case, once you know the student number, then you can uniquely identify this person. You can find that person. You can find that person's name, where he lives, his phone number, and so forth, right? So basically, a key is an attribute that assumes unique value for every instance of that entity, and therefore, and because, can be used for identifying instances in that entity. Okay. Now there are some. So to kind of finish it off, so which of the following attributes do you think would be a good key, or can potentially be a key? Well, I see several candidate keys, right? The keys that can be used as primary keys, meaning the main identifier. For example, student number has unique value for every student. Social security number has unique value for every student, and perhaps cell phone has a unique value for each student. Because I'm not aware of students, using sharing one single cell phone number, right? So there can be many alternate key, right? Or many candidate key, keys that we can potentially use as primary key. But at the end, we need to select one key identifier, one specific identifier. So in that case, we're going to use student number as our primary key. right? So primary key is a very important concept because primary keys are used to identify instances within an entity, and also primary keys are used for specifying relationships between or among entities. Okay, so make sure you understand what a primary key is, and then just know those definitions. Primary key is a candidate key used to actually identify a single entity instance, right? But there can be many candidate keys, and alternate key means like, well, alternatively we can use another primary key. Okay, and another thing to remember in relation to keys is that some keys are concatenated. Concatenated means like compound. In other words, they have several parts. So for example, if we use name as somebody's identifier, and we do use names in our daily life to identify people, but we don't, we generally don't use names in the database as a primary key. But if we were to select name as a primary key, we would see that it has several parts: last name, first name, and middle initial. So that's a concatenated key. Okay, and probably we can use it as a primary key. However, it's probably not a good primary key because I would imagine that we may have several people even here on campus that would have the same kind of last name, first name, and middle initial. Okay. Definitely, this cannot be used at the national level because in a country like United States with more than 300 million people, there should be like sometimes dozens of people sharing the same last name, first name, and middle initial. So that's why name is a candidate key, but probably not a good candidate key. Okay, so this concludes part 1 of our video presentation on ERD modeling. Thank you for listening.